Hey kiddos, we are going to continue talking about surface area and volume, but we're going to look at composite figures, okay? So as you can see, it's actually kind of similar to what you guys are going to be doing in your ELU. You're basically making a composite figure, okay? Being able to take three-dimensional shapes and stack them one on top of the other to create something different. So, for the first part here, as you notice, I have already identified which two, in this case, there are only two different types of shapes I have. So I see that we have a pyramid, and I see that we have a cube, which is also known as a prism. So, to determine the surface area of this, I want you to think of this in a sense. We're going to imagine that we are trying to paint this composite figure, okay? So notice, if I'm going to paint this, on the cube, looking at the cube, would we paint the top or the bottom? Hopefully you're saying we would not. So notice here there are no bases that we're going to be looking at. And looking at the pyramid, I'm painting, would we paint the base of the pyramid? No. So this will help us determine which formula we need to use, whether it would be total surface area or lateral surface area. So because we don't need to include the bases, we're going to actually be using our lateral surface area formulas for both of them. So let's go ahead and write them down. All right, so lateral surface area for the pyramid is 1/2 P times L. Or in other words, 1/2 times the perimeter of the base times the slant height. All right, so based on our figure here, looking at our pyramid, we were given the slant height, and that's 5 centimeters. The perimeter of the base, I can clearly see that the base is going to be a square. Well, I see it's going to have the measurement of 3. So therefore, the perimeter here would be 3 times 4, or something just 3 plus 3 plus 3 plus 3, and the perimeter is 12. So when we mathematically solve this, the lateral surface area is going to equal 1/2 times P, which is 12, times slant height, which is 5. So if we do 1/2 times 12 times 5, we end up with a lateral surface area of 30 centimeters squared. Now let's look at the cube. Cube is formula is capital P times H, where H is the height and P is the area of the base. Again, the base here is a square. You can see I already have it written out here. So these are all 3, which would lead us with a perimeter of 12. The height is given to us. It's a cube, so obviously the height is going to be the same as all the other sides, which is 3. So according to this formula, the lateral surface area is simply just 12 times 3, and that gives us the lateral surface area to be 36. Now, here's where you have to make sure you don't forget. This is a composite figure, which means you have to add those two different shapes together to get our final answer. So, the lateral surface area for this composite figure would be 66 centimeters squared. All right, let's look at the next one. For this next one, we're going to find the volume of this composite figure, okay? So notice we have a cylinder, or I should say half of a cylinder, and then we have a rectangular prism. So I've already written down the formulas, which they're the same. Capital B times H, which is height. Capital B, remember, represents the area of the specific base. Now, for the cylinder, notice I've already made the note that it's half of it. So that means this volume formula we're going to have to kind of tweak by dividing that final answer by 2 since we only have half a cylinder. Okay, so we know B means the area of the base. We know the base of a cylinder is a circle, and the area formula for a circle is pi r squared. So let's figure out what the radius is. Well, I can see here in this figure, this whole thing is 12, which means this whole thing is 12, which is the diameter for the cylinder, which means our radius would be 6. So we're going to use 3.14 for pi this time. We're going to have 3.14 times 6 squared. So 3.14 times 6 squared is 113.04 would be the capital B value. So plugging this into our volume formula, we have B, which is 113.04 times the height of our cylinder. Now be careful here, because the height of our cylinder is from here to here, okay, which is 35. So 113.04 times 35, but don't forget, we're only having half of it, so I need to divide that final answer by 2, and we end up with a volume of 1,978.2 centimeters cubed. Now let's look at our actual prism. Now, because we're looking for volume of the prism, and the prism is in its entirety, it doesn't change anything in this case. Because remember, volume is about how much can we fill into this space, right? So that's why for the cylinder, we had to take half of it because we could fill in only half of that cylinder because we only have half a cylinder. So this prism, we have the whole prism. So we're not going to actually change anything here. You're not going to have to divide anything by 2 or take away a base or anything like that, like you might do for surface area. So we know the base shape is going to be a rectangle, and dimensions of that base are 35 and 12. Now remember, you need to figure out what capital B is, which is the area of that base, which means all we have to do is 12 times 35, and we get 420 is our capital B. So for our problem, we have 420 times the height of our prism, which is here, 20. So 420 times 20 leaves us with a volume of 8,400. Now, don't forget, this is composite, so that means we got to add these two values together. So when I add them together, we end up with a grand total for our volume to be 10,378.2 centimeters cubed. Would be the volume for this composite figure. Now, I'm actually going to make you guys give you a little oh-yo problem, and I want you to determine what would be the surface area of this composite figure if I wanted to paint the whole thing. That includes just this bottom section. So, one thing that you have to keep in mind for the cylinder, okay, is that you're going to have to notice the bases is cut in half because you have half a circle and half a circle here, so technically that would make one full circle, so that means you only have one base, and we're missing a portion of the lateral. So let me give you a helpful hint here. I'm going to write down the formula and show you what you would have to do. So here's the formula for the total surface area of a cylinder, but remember, we're not painting this, we're not painting that bottom part, and we're also missing the other half of it. So essentially, what you'd have to do here is you're going to have to divide both of these by 2's, which as you can see here is going to get rid of that. So you're left with your formula being pi RH plus pi r squared. And that would be your formula that you're going to use to solve for the cylinder portion. Now on this bottom part, this rectangular prism, I do want to paint the bottom, but I don't want to paint the top base. So in your formula, you don't need to have 2 bases. You're only going to include 1 base. Okay? And then at the very end, don't forget that you need to add both of them together. All right, so here's the next problem. Now, everything depends on what you're being asked. So let's say in this case, I ask for completely, what is the total surface area of both of these figures together? Well, notice because I put the emphasis on what is the total surface area of both of these figures together, okay, we would be finding total surface area. Now, the only thing that you do have to consider here is that because they share this exact same piece, we don't have to include it in both of them when we actually do the complete total. So it's easiest if we were to remove that piece from the cone and leave it on the hemisphere. So that means my cone formula then is going to somewhat change because I'm going to get rid of the base section or base part, which is that right there. So I'll get rid of that part. So really, on the cone, I'm actually looking for the lateral surface area because the hemisphere part is going to keep that bottom base. Okay? So let us solve this problem. 2 pi r squared. So we're going to use 3.14 again for pi. So you got 2 times 3.14 times the radius is given to us as 3.5, and we need to square it. So 2 times 3.14 times 3.5 squared is 76.93. Now let's find the other surface area, which is pi times r times slant height. Pi, we're going to use 3.14 times the radius, which we already know is 3.5, times the slant height, which, they didn't give us a slant height. They gave us the actual height of the cone, but not the slant height. So we're going to use Pythagorean theorem. A squared plus b squared equals c squared. So, little side note here, we're going to have 3.5 squared plus 10 squared equals c squared. And when I add those, we get 112.25 equals c squared. Last step, take the square root of that number. And we end up with 10.6. So the slant height, we will say 10.6. So when I multiply 3.14 times 3.5 times the 10.6, we get 116.5. So now I just need to add those two values together. So 116.5 plus 76.93 gives me a grand total for the surface area for this figure to be 193.4 centimeters cubed. All right, now let's look for volume. We're going to do both for this one, okay? So now let's do volume. So let's write those formulas down first. All right, so here are our formulas. This one is for the hemisphere, and this one here is for the cone. We're finding volume, so we don't have to cut anything in half in this case or anything like that crazy. So for the hemisphere, 2/3 times 3.14 times the radius, which is 3.5, and we're going to cube that radius. So we get 89.8. And now for the cone, you have to first figure out what capital B is, which is area of the base, which is a circle. So that's pi, which we're going to use 3.14 for pi, times the radius, which we already know is 3.5, and we're going to square that. So 3.14 times 3.5 squared is 38.5. So now when I plug that in, we would have 1/3 times the 38.5 times the height, which was given, which was 10. So when I multiply that, we get 128.3, and all we have to do is add those together, and our final answer is, again, 218.1 centimeters cubed for the volume.